Relations and Functions Part 2. Please, before you view this video, it is highly recommended that you view the video on Relations and Functions Part 1. In this video, we shall find domain and range of relations and functions. The relations and functions will be written as rules or equations. Remember, in the first video, we said that relations and functions can be written in 5 ways. It can be written as an ordered pair. It can be written as a mapping or correspondence. It can be written as a graph. We can represent them as a graph. We can represent them as a rule or as an equation. Remember, equation is known by an equal sign. Okay, equation has an equal sign. Expressions connected by an equal sign. Then it can also be represented as a table. So these are the 5 ways by which we can represent relations and functions. And in the first video, we found the domain and range from ordered pairs when they are represented as ordered pairs, and also when they are represented as a mapping. We found that the domain and range in the other video, and we represented the domain and the range as a set. We represented them in set notations. Okay, in this video we shall find the domain and range when the relations and functions are represented as a rule or as an equation. So this is quite different from when they are represented as an ordered set or as a mapping. Those ones are pretty much easy. When they are represented as an equation, we have to be more careful when finding the domain and the range, especially the range. Okay, so we have 25 questions here, and as usual, what I recommend to my students is that I will do the first question. You look at it, you listen. Then, before I do the second question, you can pause the video and do it on your own. Then, after doing it on your own, you can then play it back and see whether we got the same thing. Here, we shall find the domain and range of relations and functions represented as an equation. Then we shall do that extra work in representing that domain and range in interval notation and in set notation. So we kind of have much work to do. Okay, let's get started. Now, recall what is domain? Domain is the set of all the x values. Okay, domain is the set of all the x values or all the input values in the ordered pair. In a relation of ordered pairs, domain is the set of all input values in the ordered pair of the relation. And range is the set of all output values or all y values in the ordered pair of the relation. All right. Now we will say, for now, let's say let our domain be D, and then let our range be R. Yeah, that's what we are going to use in this video. So it will kind of save us some time. Remember, the domain is the x set of x values, and range is the set of y values. All right. So question 1, y is equal to x. Now, when you are given this, the question says decide whether the relation defines y as a function of x. That's the first question. Second question, give the domain in interval notation and in set notation. Third question, give the range in interval notation and in set notation. So this is like 5 questions. Okay, each question we have to do 5 things. First of all, we have to find out whether the relation is a function or not. Question 2, we have to find the domain of the relation in set notation. Question 3, we have to find the domain of the relation in interval notation. Question 4, we have to find the range of the relation in set notation. And then question 5, we have to find the range of the relation in interval notation. So take note of this. For each question is 5 things you have to do. Now, when you have this first one, y equal to x, of course, looking at it, for each input x, there is a unique output y. No 2 input will repeat if you have this. So this is a function. This relation is a function. Because when x is 1, y is 1. When x is -1, y is -1. When x is 2, y is 2. So it's a function. Now, how do you find the domain? Listen and listen well. When you want to find the domain of an equation, you ask yourself this. First of all, we are considering only real numbers. Only real numbers. What are the real numbers? Any number on the real plane. In other words, on the number line. On the number line, any number on this number line is a real number. 0, of course, is in the center. 0 is neither positive nor negative. Okay, 0 separates the positive numbers from the negative numbers. To the right of 0, you have the positive numbers. To the left of 0, you have the negative numbers. Any number on this number line, rational numbers, irrational numbers, even numbers, odd numbers, prime numbers, decimals, fractions, perfect squares, perfect cubes, all of them exist on the real number line. Now, the only numbers that we are not going to consider are complex numbers. Okay? Those ones, we are not going to consider them. But every other thing on the real plane that exists on the real plane, we shall consider it. Now, you now ask yourself, when you're given this equation or rule, what are all the possibilities of the input? I mean, can you put any number as an input for it to give an output? Can you put any number as x for it to have a result as y? Okay? And x can be any number. So all the numbers that you can input, all the numbers that you can input for it to have an output is the domain. So x can be any real number. It can be decimal, it can be fraction, it can be any number, because if you use any number here, if you say x to be -5, then y will be -5. If you say x to be 1/20, then y will be 1/20. So the domain here, in interval notation, it will be from -infinity to infinity. Okay? That's the interval notation. And then in set notation, of course, we have our braces. This is our braces. X such that x is real. X is real. Or x is a real number. You can write it as x such that x is real. Or you can write it as that the domain is a set of x. That is how we say it. Domain is a set of x such that x is a real number. A real number. You can write it this way. Or you can also write it that domain is a set of x such that x is an element of the real number. Okay? R means the real number, R, uppercase R. So this means that x is an element of real number. Any of these ways is fine. You can write it, any of these ways is fine. Okay, remember, this is an element of, it's called epsilon. Epsilon. Okay, it means element of. Element of. When you do your sets, yeah, you have it. It's not E. This is not E. No. It means x is an element of a real number, of the real set. S is an element of the set of real numbers. That's what it means. X is such that X is an element of the set of real numbers. Element of, which is epsilon. Epsilon is a Greek alphabet. Okay? So that is our domain. And then what will be the range? The range will be any number, because since the domain is any number, of course, the range will be any number. So the range R will be a set of Y such that Y is also real. So our range is a set of Y such that Y is also real. Okay? And then what is our range in interval notation? The range will be from negative infinity to infinity. That is the range in interval notation. Okay? Now, we are doing this. I should have also written this. When you write let the domain be D and range be R, you should also write let Y be a function of X. We are taking Y to be a function of X. So this is what you should try before you now use all these letters. Okay? Remember, domain is a set of X, which is the input. Range is a set of Y, which is the output. Okay? You can also write, some textbooks will write range as function of X, such that function of X is an element of R. I mean, some textbooks will write it like this. It's still the same thing because Y is a function of X. Some textbooks will write it this way, function of X, such that function of X is also an element of the set of real numbers. So it's the same thing. But here in this video, I shall be using just X and Y, then D and R. I shall be using X and Y, D and R. Okay, so I guess we've done question 1, so we can now do the rest of the problems. Question 2, Y is equal to negative X. Here, as you can consider also, X could be anything. But whatever X is, the result will be negative of that. If X is 2, then the result will be negative 2. If you input 2, the output will be negative 2. If you input negative 2, the output will be 2. So here, this case, X, this is also a function. Of course, it is a function. It is a linear function because every input has a unique output. No input will repeat. No input will repeat. No input will have two different outputs. No. Every input will have a unique output or an exactly one output. So this is a function. Then the domain, of course, will be from negative infinity to infinity. The domain in set notation will be set of X such that X is real. X is real. The range in interval notation will be negative infinity to infinity. Range in set notation will be Y such that Y is real. Okay? Question 3. Y equal to X plus 4. Here, this is the same thing. It is a linear function. This is a function because every input will have exactly one output. Okay? The domain is the same thing as this. The domain will be negative infinity to infinity because anything you put here will have exactly one output. Anything you put as the input will have exactly one output. And you can put anything. Anything you put will have an output. So that's why X could be anything. X could be anything on the number line. Any number on the number line. That's why it's from negative infinity to infinity. Right? And Y the same thing. Y could be anything on the number line from negative infinity to infinity. So this is the same thing as this. This answer here is the same thing as that. Question 4, we could actually save some time, so we could do the more challenging questions. Those ones are coming. Question 4, you see, is the same thing. It's a function, it's a linear function. Linear function because the highest degree of x is 1. Highest degree of the variable in the function is 1. Of the independent variable is 1. It's a linear function, then the domain is from negative infinity to infinity, right? Any real number. Domain is any real number. X is a real number. Range is a set of y such that y is a real number. Okay? Range also in interval notation is from negative infinity to infinity. So this is the same thing here. It's also a function. And it's the same thing. Question 5, y equal to x squared. Okay, this is where we have to be careful here. Y equal to x squared. Now, look at this first. Is it a function or not? Is the relation, of course it's a relation because every input has an output. Relation is a set of ordered pairs, input, output. First component, second component. X, Y. So, any number you put as x will have a result. Any number, any real number you put will have a result. Okay. And you can put any number. So, what is the domain? Is there any number that you cannot put so that it will not have a result? No. You can. X can be 0.01, x can be negative 1 over 1,000, x can be 200, x can be 5, okay? X can be anything at all, 1.41456, okay? X can be square root of 35. If you do that, it will have a result. All right, so this is, of course, this is a function. This is a quadratic function. It's a function because there's no, here you see that no input will have two different outputs. No way. If we kind of try it, if we try it to map x onto y, defined by y equal to x squared, of course, negative 1, 1, negative 2, 2. Negative 1 and 1 will give you 1, negative 2 and 2 will give you 4. Okay, remember, when we discussed in the first video, two inputs can have the same output. Yes. But no input can have two different outputs. So this is still a function. It is a quadratic function. Okay, what is the domain? Domain could be anything. Any number you put here will have an output, y. Any number you put. So domain D is from negative infinity to infinity. Okay, this is interval notation. In set notation, domain is a set of x such that x is real. Okay? Now, let's come to the range, y. Is it possible for the square of any real number to be negative? Think about it. Is it possible that the square of any real number will be negative? No. The answer is no. It's not possible. Because any real number you put here, even if it's negative 1, if you square negative 1 all squared, it's going to give you 1. If you do negative 2 all squared, it will give you 4. If you do negative 3 all squared, it will give you 9. So all the output will be positive. And then what you now ask yourself is this. What is the, because 0 divides the positive numbers from the negative numbers. Here, you see that y could be 0 up to positive infinity. Because if you do negative 1 all squared, it will give you 1. So if you start from that middle 0, you see that it starts from 0 and it includes that 0. It does not include, it does not exclude it. It includes it. So it's going to be from 0. And then when you square all other negative numbers, it's going to turn to positive. Okay? So the range here, the range will be, for this question 5, for question 5, we now see that the range here will be from 0 is included, up to positive infinity. From 0 to positive infinity. This is the interval notation. Set notation will be, range is a set of y such that, right, y is greater than or equal to 0. You put greater than or equal to 0. Y is real and is greater than or equal to 0. That is the set notation. Set of y such that y is greater than or equal to 0. If you don't put this equal to 0, it's wrong. 0 is included. Okay? That is for 5. Now, before we do question 6, let's kind of do another type here. What if we have y equal to negative x squared? What if we have something like this, negative x squared? Now, listen and listen well. This means negative 1 times x squared. That is what it means. Please, x squared, negative x squared, these are not the same thing. They are not. They are not. Because students make some mistakes here. They think that x squared and negative x squared is the same. It's not. 3 squared is not the same as negative 3 squared. Negative 3 squared means negative 1 times 3 squared, which is negative 1 times 9, which is negative 9. Now, what is the same as this? If you have negative x all squared, then yes, this will be x squared. Then this will be x squared. Okay? If you have 3 squared, it gives you 9. If you have negative 3 all squared, so that means that negative 3 will be in parentheses, and then you square it, then this is now 9. Then it works. But when you just have negative x squared, it means negative 1 times x squared. It's not the same thing as x squared. So please take note of that. Now, how do we find this now? How are we going to find it? This is a function. This is a function. Okay? What is the domain? The domain, of course, can be anything. Domain is from negative infinity to infinity. And then in set notation, domain is x such that x is any real number, or x is a real number. Okay? Now, what is the range? What do you think will be the range? The range could be what? Because here, if we choose x squared, all will be positive from 0. But if it's now positive, remember, it will be multiplied by negative 1. And because it's multiplied by negative 1, it's all going to be from 0 to negative. It's no longer going to be positive because the x squared itself, okay, this x squared itself will be positive no matter what x is. The x squared will be positive. But guess what? If it's now positive, it's going to be multiplied by a negative 1, which will make it negative. Now, 0 is still included because if you put 0, 0 times negative 1 will still give you 0. 0 times any number will still give you 0. So, 0 is still included. But it will be from 0, and then moving down to negative infinity. None of it will be positive. Okay, because it will be multiplied by negative 1. So what is going to be the range now? The range will be, because it's going to be like this. From 0, negative 1 times 0 is 0. Negative 1 times 1 is negative 1. Negative 1 times 2 squared, 4. Negative 4. Negative 1 times square root of 2 all squared is negative 1 times 2, which is negative 2. So it's going to be like this. So this will be from negative infinity to 0. 0 is included. Okay? 0 is included. And then what is it in set notation? What is it going to be in set notation? Set of y such that y is less than or equal to 0. So you see, it's just the other way around of x squared. So please take note of it. You can call this number 6. We can call it number 6. And then number 6 becomes our number 7 and the rest of them. Okay, let's go to number 7. Let's now do that as number 7. Our number 6 becomes our number 7. Y equal to x squared plus 3. So here, y equal to x squared plus 3. So what do you think x could be? Anything. Okay, you can x, if you put x as anything, you square it, add 3, it will still give you a result. So domain could be anything. Yeah, this is a function, it's a quadratic function. No input will repeat itself. Every input will have a unique output, or exactly one output. The domain is from negative infinity to infinity. Domain in set notation will be x such that x is an element of the set of real numbers. What will be the range now? Be careful, what will be the range? Now the range, this x squared, is going to be from 0 and positive. From 0 and positive. The minimum is 0. Okay, because if you put negative numbers and square it, it will give you, it will still give you positive. So 0 is the minimum. So 0 plus 3 is 3. So it's going to now start from 3. It's not going to start from 0. If it was x squared, then it will start from 0. But 0 is the minimum here, and that 0 plus 3 is 3. You can now, if you now do negative 1 all squared, it will be 1, 1 plus 3, 4. So, but it will be from 3 moving to the right, from 3 and more. Okay, so this will be from 3 is included, to infinity. Remember, it's going to be like this on the number line. Assuming it was the number line, it will be from 3 to infinity. 3 is included. From 3 going like that. Okay? If we did it on a number line. Now, what will be the set notation? This is the range, I mean. Range. So, what will be the set notation for the range? It will be a set of y such that y is greater than or equal to 3. Question 8, we have y equal to x squared minus 5. So the same thing we did here. We apply here. Of course, this is a function. This is a quadratic function. Domain will be from negative infinity to infinity. This is interval notation. Domain in set notation will be a set of x such that x is a real number. Okay? What will be the range? The range, x squared, will be all non-negative. Okay? 0 to positive. Yeah, 0 and positive. Now, what is the difference between a positive numbers and non-negative numbers? Non-negative numbers include 0 and the positive numbers. But positive numbers does not include 0. Okay, take note of that. So this x squared will start from, is a non-negative number because it will include 0. And then all positive numbers. Positive numbers does not include 0. 0 is not positive, it is not negative. It just separates the positive numbers from the negative numbers. To the right of 0 are the positive numbers, to the left of 0 are the negative numbers. So the range here, the minimum 0, 0 minus 5 is minus 5. So this will include minus 5 upwards, because if you do it like this, look at the way you can do it. 0 is the minimum, 0 minus 5 is minus 5. Then the next one will be, any one will be positive numbers. So let's say 1. 1 minus 5 is minus 4. 2 minus 5 is minus 3. 3 minus 5 is minus 2. 4 minus 5 is minus 1. Okay, 5 minus 5 is 0. 6 minus 5 is 1. So you see, it all takes from negative 5 up to infinity. So this will be from negative 5 inclusive up to infinity as the interval notation. Then the set notation will be, range is a set of y such that y is greater than or equal to negative 5. Our question 9 is y equal to x cubed. Okay, look at this. And that will take us, that we will also look at x squared now, since we are talking of x cubed. Let's go back to x squared. For x squared, we found that the, of course, the domain could be any real number, okay, but the range will be from 0 to infinity, right? Yeah, because the square of any real number is what? The square of any real number, excluding 0, is going to be positive, right? The square of any integer, square of any real number, excluding 0. Square of 0 is 0. Then square of all other real numbers will give you positive. So from 0 to positive, okay? Or you just say a set of non-negative numbers. Set of non-negative numbers. All right. Now, this applies to x4, x6, x8, x10, x12, all even powers of x, all even exponents of x. Okay, quartic, and all higher even powers of x. Here, this cubic equation, this is a function. This is a cubic function. Now, the domain could be anything. The domain could be any real number. So, domain interval notation is negative infinity to infinity. Set notation will be from a set of x such that x is an element of the set of real numbers. Now, what is the range? What is the range? I should write R, not Y. Why am I writing Y? Don't mind me. Okay, so what's the range here? If you cube positive numbers, it will give you positive numbers. If you cube negative numbers, it's going to give you negative numbers. If you cube 2 cube, 2 times 2 times 2, 8. 2 times 2, 4 times 2, 8. If you now cube negative 2, all cube. Okay, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So, this is not going to be all positive from 0, no. If you cube 0, it gives you 0, so it's included. So, here, for the cubic, the negative numbers are included, 0 is included, and the positive numbers are included. So, this will be from negative infinity to infinity. Okay, and then the set notation will be a set of y such that y is also an element of the set of real numbers. That's the same thing for cubic function. Yeah, and this cubic function will apply to x5, x7, x9, x11, x13. All higher odd powers of x, or all higher odd, all higher odd exponents of x. All higher odd exponents of x. While the x squared would apply to all higher even exponents of x. Okay? 10, question 10. We're getting there. I'm trying to solve so many varieties so that you will have a good understanding after this topic, after solving all this. Now, y equal to x plus 3 over 5. Okay, if you look at this now, you look at the denominator is 5. Okay, this is a linear function. So this is like saying y equal to x over 5 plus 3 over 5. This is like saying y equal to 1 over 3x plus 3 over 5. So x could be anything, y could be anything. Okay? I mean, it's still a linear function. X could be, just like when we did the first linear function, x plus 4. When we did linear functions like x plus 4, 2x minus 5. The domain could be any real number, the range could be any real number. Okay? The same thing applies to this. Don't be scared that this is a fraction. No. You see, it's a fraction, but you can kind of rewrite it to see that it's that is a linear function. Slope is 1 over 3, and y-intercept is 3 over 5. Your mama ex-boyfriend, y equal to mx plus b. Anyway, so that's the same thing here, that's the same thing there. Now, question 11, so here you understand it. Domain and range are real numbers. Y equal to 2x minus 7 over 3, the same thing, because this is like saying that y equal to 2x over 3 minus 7 over 3. So x could be anything, y could be anything. Okay? Question 12. Question 12. Y equal to 3 over x. Okay, now, this is a function. Now, this is a function, of course. This is a linear function. This is a linear function. Now, 12 is also a function. Okay, but here you have the x as the denominator. So, let's just think about it now. Okay, this is a function. You ask yourself this question. Is there anything you can put as x such that it won't have an output, it won't have a result? Is there any number that you can put as the input such that it will not yield an output? If you use x to be -1, then 3 divided by -1 will give you -3. It has an output. If you do x to be 5, then 3 divided by 5 will give you 0.6. It has an output. 0.6 is a real number. Now, but is there any number? Okay, is there any number that you can use as x such that you won't get a real output? What I mean by a real output is an output that is a real number. So, do in your calculator, press in your calculator 3 divided by 0. Now, if we have 0 divided by 3, this gives us 0. But if we have 3 divided by 0, this gives us undefined. In your calculator, you will see E, error. Some calculators will write E, error. So this is 3 divided by 0 is undefined, or error, or E. So it won't work with 0. So x is going to work with any other number, but not 0. It's going to work with any other number, but not 0. So the domain will be from, and this is how you can find the domain. here is 0, it will work with any number from negative infinity up to 0. 0 will not be included. It will not be included, so you put an open interval. Okay, you put a parenthesis. Now, union from 0 to infinity. Anything except 0. Anything except 0 will work. 3 divided by negative 0.1 will work. That would even give you a negative 30. Okay, but it won't work for 0. 3 divided by 0.1 will work. That will give you 30. The only thing is that it will not work with 0. So 0 is not included. If you're writing the interval notation, you write it this way, that 0 is not included. Now, for the set notation, it will be a set of x such that x is real, but on the condition that x is not equal to 0. Okay? Now, you can write it, if you like, you can write it this way, set of x such that x is not equal to 0. You can just write it like this, that's fine. Yeah, you can write it this way. Well, here, whatever we are doing here, we are talking about real numbers. Okay? So, that's the domain. Now, what will be the range? What do you think will be the range of that? You come to the range now, the result, the output. 3 divided by x could be anything. 3 divided by x. Could it ever be 0? Is a question mark. Is 3 divided by x, can it ever be 0? Assuming you do 3 over x equal to 0. You can have 3 equal to 0x. And then you have 3 equal to 0. This is a contradiction. This is a contradiction in math. So, in finding the range here, it can't be just anything. No, it cannot be just anything. It's going to be, because this will be, it can't be, the output will never be 0. It's not possible for you to divide 3 by something to give you 0. So, the range can never include 0. You see, it's a contradiction. But it can include any other thing, okay? Assuming we do 3 divided by x to be 0.1, right? That means 3 will be 0.1x, right? And then x will be 3 over 0.1. X will be 30. So, x could be 30 to give 0.1. So, the range could be 0.1, it could be negative 0.1, it could be 0.002, it could be negative 0.005, it could be 5, it could be 10, the range, you can do it. But it will never be 0. The range, the output will never be 0. But the output could be any other thing except 0. So what will be the range here? The range will be from negative infinity, it could be anything, 0, but not including 0, union 0 to infinity. And then it will be a set of y such that y is not equal to 0. Y can never be 0. Or you can say range is a set of y such that y is an element of the real number, y is not equal to 0. Y is an element of the set of real numbers, and y is not equal to 0. Remember, in the last video we talked about braces. Please, in set notation you must write this. Do not write parentheses or bracket. Please, no. In interval notation you use parentheses and bracket. In set notation you use braces only. And I taught you how you can write your braces. You draw a line like this. And from here you draw the line like this. In closing it, you draw the line like this, and from here you draw it like this. Something like this. Okay? Now, we will stop here. Question 12. We'll stop here for now. And the next video we shall finish the rest of the questions. Thank you so much for listening.